Good evening, everyone, and welcome to the Tuesday evening absent webinar series. Tonight, I have with me Jonas Olofsson from the University of Stockholm. And I'm also joined by Aidan Kirkwood, who is helping out on the tech in his wireless headphones. So tonight, we're going to be talking about smell training and what happens in the brain when we smell train. This is a subject that has interested me greatly for a long time. So I think I'm going to turn over to Jonas right now and ask him to introduce himself and do tell us a little bit something about your work and your interest in smell training.
Thanks. It's great to be here, Chris. So I'm a cognitive scientist by training, and so I have a PhD in psychology. I'm a professor in psychology, so I do experimental work. I got interested in the sense of smell when I heard that people with Alzheimer's disease had severe smell impairments. So I started a project for my PhD to try to see if we could predict who would get Alzheimer's disease, who would get cognitive decline based on their smell results, basically. And that turned out to be a quite interesting result. So that there were some interesting connections there.
Right.
And when I gave talks about this topic to people, they often said, okay, now that I heard your talk, I'm going to go home and smell train, and hopefully I won't get Alzheimer's disease. And I said, not so fast. We don't know anything about that. But that kind of created a thought in my head, and that got me interested in smell training, actually. So I'm coming to that point from an aging perspective and not from sort of a patient perspective. But that's sort of where our interests intersect.
Right, good. So I've prepared some questions for you, and these are questions that I've asked myself over the years as I've read about smell training, and I thought I would put each question to you, and then maybe we could discuss a little bit what your answer is, and by the way, and Aidan is going to be watching the question and answer bar. So if you do have questions, please put them there. The chat bar is really just more for sort of housekeeping. If you find that you can't get, if you've got a problem logging in or something like that, you can use the chat bar. But please, if you've got questions for the panelists, please put them in the Q&A bar, which you'll find the button at the bottom of your screen. Right, so my first question for you is about the chemical senses in general, and whether you are man or mouse or amoeba, you have the chemical senses are working for you to interpret your environment. And can you tell us a little bit about this? And why is olfaction so different from vision and hearing?
Those are really big and important questions. So cells communicate chemically. They receive chemical signals and they transmit chemical signals. So that's a sort of a very basic way for communication in biological systems. And one study that I thought was particularly cool was published in the 60s when they found that amoebas in a petri dish were able to actually swim towards a sucrose solution. So they could pick up on the gradient of sweetness in the water and move towards it. So that shows you just how sort of fundamental chemical sensation is in nature. And it's obviously important to avoid things that will harm you and to attract you to things like sweets, whether you're an amoeba or a person. We're mostly attracted to sweets and high calorie food. Yeah. But the second part of your question, I think it's really too bad that the sense of smell is somehow neglected. It's been neglected in research, and I think it's been neglected in the wider community. Perhaps now with COVID-19 having such a big impact on the sense of smell, that might change. I've heard that from a lot of people, actually colleagues who told me
Right.
after getting COVID, now I understand why the sense of smell
Right.
is important. So
Right.
maybe
Right.
that will change.
Yes. Well, let's hope. That is certainly that it comes up in the Facebook group a lot. We talk about this subject, and certainly the people from the original Absent Facebook group have been, mentioning this as well. We've been suffering all these years. Maybe now that we have this new crop of people who have just piled in, all of a sudden there will be more awareness and more funding given to research into olfactory science. So that would be really important.
So,
Can you comment at all about how olfaction is different from vision and hearing? I mean, we just think about the five
yeah.
senses.
Mm.
Of course, I think there are more than five senses, but if we just take the basic five senses that we know about,
Mm.
and I think a layperson might just sort of think about all of them as being equal, but I think they're located in different parts of the brain. So is there
Yeah.
anything that you can say about that will help us understand why loss of smell might be different than loss of vision or hearing?
Right. Yeah. So those are really key issues, and smells, as you know, they project into really central parts of the brain, and so I think you can't really explain the features of the sense of smell without considering what the smell brain is all about, what the regions are that it connects to, and how it's different from let's say vision. So the sense of smell connects to first the piriform cortex, which is sort of where objects are perceptually recognized, I would
Okay,
say.
is that all objects are, does the same thing go for vision as well? Does
Yeah,
that
so
happen at the
both,
piriform?
yeah, so the visual cortex has object mechanisms. So we can recognize a chair, we can categorize them, we know sort of, we have perceptual categories like that. And some research points to a similar thing happening in the sense of smell, so that the piriform cortex has templates, has categories, and it tries to fit what's the incoming smells, it tries to fit them into these templates, and that's what the piriform cortex does, according to the studies that I think are trustworthy. So there are some similarities, but what happens from that point is very different, because the piriform cortex is very well connected with the amygdala, which creates emotional arousal, for example. So smells are often emotionally evocative. It's also connected to the orbitofrontal cortex, which seems to have more of a value-based function. And it also integrates different senses with each other, but it gets direct input from the olfactory cortex. So good or bad, basically, we tend to evaluate smells as either good or bad. Then when we think about it some more, we might have a more nuanced opinion. But we tend to either reject or accept
Right.
smells. Uh,
Right.
so those emotional parts are, I think, a feature of the organization of the olfactory brain.
It's interesting what you say about this tendency, or not, this automatic thing that we do, which is to recognize a smell as either a good, accept or reject. And I can remember when my smell loss was total, or let's say when it had come back to the point where just the beginning, so I could receive smell messages, but I couldn't interpret any of them. So it was just like vague, like white noise in the background. And it was very disconcerting to know that I was in the presence of a smell, but not be able to understand whether it was a good smell or a bad smell. I found that very, it was a very unpleasant feeling,
Yeah.
and yeah.
Yeah. So there is a risk associated with not being able to understand the olfactory environment, because it might be harmful, right? So you want to know what it is. So that must be
Yeah.
tough.
Mm.
And we tend also to feel threatened by smells that we don't recognize, right? So that's sort of a default mode for
Right.
us.
Right.
But after a while, we develop these patterns based on previous experiences, and then we can have more positive evaluations of the smells that we are perceiving. And a lot of that stuff happens in the primary olfactory cortex,
Mhm.
the piriform cortex. So that's a very interesting region. And since I'm a psychologist, I'm also interested in sort of what the brain is projecting onto the piriform cortex, because the piriform cortex doesn't just receive signals passively. It's always sort of a trade-off between what's coming in and what's already inside, and how do we actively interpret what we perceive. So in my opinion, 50% of what we are smelling is a matter of our expectations.
Absolutely. And we'll get on to that, because
Yeah.
for me, that is a very crucial part of smell training. But well, let's stay with that right now,
Mm-hmm.
because when I explain to people how they should smell train, I think the common misconception is that smell training is something that happens between the jar and the nostril, and people feel that if that link is not if that's not an intact connection between those two places, then there's really no point in smell training. But of course, smell is a long cascade of brain processes, and in order to feed the olfactory bulb, you have to sort of think, you have to employ your memory and engage your mind in all of that. Can you elaborate on that a bit? I think it's a really important point that
Yeah.
I think people should understand.
Yeah. Yeah, so I think it's best described in terms of patterns of brain activity in the piriform cortex. And when we hear the word that signifies a well-known smell, let's say lemon, the brain projects a template, a perceptual template, onto the piriform cortex. So it pre-activates the smell brain, prepares it to smell lemon. And we can see that we do a lot of reaction time studies in my research lab. So we give people these cues. We say that it's lemon, we say that it's rose, lilac, or whatever, and then we wait for a couple of seconds, and then we give them the smell.
Right.
And what always happens is that they are quicker, because they have two buttons to press, either one for matching, when the smell matches the cue, or when it doesn't match, they press a different button. So it's just smell match or non-match. And every time we do this, we find that people are quicker in saying yes when the smell matches to what they were prepared to smell. Even if there's only two smells in the set, they're still quicker in confirming what they were prepared to smell,
Mm.
compared to when there is a surprising smell. So that tells you that these predictions are quite important. And I was able to be part of a study with Cristina Celano at Northwestern University, who had access to epilepsy patients who were undergoing surgery. So they had implanted electrodes in their brains,
Mhm.
and they signed up to be part of this study while they had these electrodes. So we could measure exactly what happened when they heard the smell cue. So
Right.
they got the word mint or rose,
Right.
and then after a few seconds they got mint or rose.
Right.
And what we could see was that the sound cortex, the hearing cortex, and the olfactory cortex, they started oscillating together.
Wow.
Uh, and that seemed to be necessary for them to perform the task. So
Interesting.
when they got it right, when they were able to make the connection, you know, what I smelled and what I heard was the same thing, then you had this sort of synchrony between the two brain regions.
Amazing.
And this all happens before they even smell anything.
Wow.
So I thought that was a very very interesting result, and it goes to show that a lot of what we are smelling is actually affected by what the expectations are, if we're focused on the smell training, etc.
So would you be able to make the same observations? Obviously you wouldn't, it would be manifested in a different way, but could you make similar observations about brain activity using an fMRI scanner? And could you, if you were to say, put someone in an fMRI scanner and give them lemon to smell and give them the cue, and then give them the cue, but not the smell, would you expect to see the same kind of brain activation pattern?
Yes, more or less. Well, those studies have been done. There's been a few of studies similar to what you're saying. There was an early study from the 1990s, which had the title, Reading Cinnamon Activates the Olfactory Cortex. So reading the word cinnamon creates some kind of activation in the smell brain. And at that time, we didn't know really if that was just like is that activity meaningful? Is it important? Or is it just that we have an association, but it doesn't really mean anything? But now with the study that I mentioned with Christina Zelano, and she also had a different study published where they gave, this was an fMRI study, where they gave a cue and looked at the pattern of activation in the piriform cortex and compared that pattern to when they actually smelled that smell. And the pattern similarity was higher when there was a match. So preparing to smell lemon seemed to pre-activate the pattern of lemon.
Right.
Yeah, so that goes to show that, again, the brain predicts what you're smelling.
Fascinating. And I think it's fair to say that we smell train with a lot of our brain. It's not just something that happens in the nose.
Yeah.
And so when I try and encourage people to smell train, even in the absence of smell, there is good scientific foundation why this is a good idea.
Yeah, I think so. It's definitely a more complex task than many people might think. We engage much of our brains when we smell, because smell is an active process. It's not just whatever comes into our nose. The brain is always active and making predictions. And I think that's why those of us who have a good sense of smell, when we remember a smell, it's usually when it was unexpected. You walked into someone's house and it smelled very strange.
Right.
Or something like that. Then you remember it, right? But if you make a meal, your favorite meal, and it smells just like it always smelled, you don't think about it very much. So I think one of the reasons, maybe going back to your question before, one of the reasons why the sense of smell doesn't get much credit, it's because the brain is always one step ahead. So the brain is predicting what we're going to smell most of the time, and it's most of the time correct. So there are a few surprises, and the surprises, those are the events that we remember.
Right. Fascinating. Now I can see that there are a couple of questions in the Q&A. So Aidan, would you like to ask us a few, and what
sure, yeah, no bother. Sina asks, I've just received my smell training kit in the mail. Is there a particular time of the day I should use it?
I am not sure that any particular time is better than the other. What do you think, Chrissy?
Well, I mean, the goal is that people should smell train twice a day at a minimum. And if it's convenient to do that morning and evening, so I tell people to keep the jars at their bedside. and do it right when they wake up in the morning and before they go to bed at night. But I mean, I have some in my office, so you know, I have opportunities for smell training everywhere, which is also a good idea. Um,
Yeah.
there are people who say that when they wake up in the morning, they're a little bit stuffy, so they don't necessarily have as good a sense of smell first thing in the morning. But I think for the sake of routine and, you know, just getting into that rhythm of doing it daily, it's probably best morning and evening.
Yeah, that sounds wise to me. The most important thing is that it gets done.
Yeah.
And I can add something also that about training before you go to bed, that is often good for memory consolidation to the extent that we can smell anything when we smell train. The brain tends to process those things during the nighttime. So there are.
Are you saying that smell training helps you process the smells to remember them, or other things that happen to you during the day?
So the studies that I'm referring to would be related to the smells,
Right.
so that it would help to remember the smell. So when you sleep or take a nap after doing something, the brain tends to process that and helps you encode whatever you have done.
Right.
And there are some interesting brain imaging studies also where they have presented smells during sleep. So they train people to remember things and associate things with smells during the daytime. And then when they sleep, they get the smells while they're sleeping. And the smells doesn't wake them up, so they are still asleep. But the day after, they perform better on the memory task. So the smells sort of evoke these associations from what they tried to learn the day before. So I thought that was fascinating. Was a fascinating study.
Wow. Anything else, Aidan?
Sure. Someone asks, will smell training also help my taste recover?
Well,
go ahead.
Yeah, so smell and taste are intimately linked. Most people can't really tell the difference between smell and taste because they're all so mixed together. When we eat and we chew, we pump air through our nasal cavities and out through the nose, and we smell the food that we are eating. So that people often tend to refer to that as taste. When it is in fact smell. So in that sense, it will help.
Yeah. Although it has to be said that there are many people who have had COVID-19 smell loss who have also experienced impairment of true taste, as well as chemesthesis. So that's
Right.
not unknown. And also the sort of recovery outcome of that is we're still learning. But people seem to regain the gustation, which is salty, sweet, sour, bitter, and umami, a little bit quicker than they are regaining their sense of smell.
We have a question here which is quite related to what you were speaking about earlier, Jonas, about the anticipatory response. So we have someone here asking, if you have anosmia, does your mouth still water when presented with certain foods, even if you can't smell?
I don't know of any study to that effect. That would be an interesting study to run, but I would assume so, as long as you have those associations intact. I would assume so.
I know that, I mean, I've been my own personal experience, and we've discussed this in the Facebook group, that you can, in the beginning anyway, you can have craving for a certain food, and then you go to eat it, and of course your experience is you know, non-existent. And then people tend to, at that point, very often will overeat in an attempt to finally get the flavor, and then that's a very disappointing experience.
Yeah.
But I do think that what you do lack completely when you have no sense of smell is that moment when you would smell something where you would normally say, oh, I'm really hungry, I can smell, you know, whatever bacon cooking, and then you get a craving, and that seems to not happen for obvious reasons. So
Yeah.
yeah. Oh, Aidan, you've muted yourself.
Do you want me to keep going with the questions,
Yeah,
Chrissy?
let's go. I can see we've got 10 questions.
Yeah, yeah, sure. That's fine. So I have Stephanie here asking, can you talk about phantosmia? What's going on in the brain when you experience a smell not triggered by an actual odor?
Yeah, I'd be really interested in your take on this, Jonas, because we do have plenty of people that have phantosmia, and I think I'd like to hear what you say, because I have a theory about some kinds of phantosmia. So what are your thoughts on that?
I should say that I don't consider myself an expert on phantosmia. We published one paper on phantosmia a couple of years ago, and it was in an middle-aged and aging population, where we looked at the type of smells that they reported and what are the predictors of it. What we found was that happens to about 5% in the general population that they have phantom smells, and most of these reports were of kind of a burnt sensation. And I don't know what's going on in the brain with people who have this sensation, but my default speculation would be that it is some kind of noise in the brain, that because what we know about the brain generally is that it's always trying to differentiate what is a true signal and what is noise, because there's so much firing everywhere in the brain. The brain has to see a pattern somewhere. And if the sense of smell is distorted, the brain might misinterpret the activity that's going on, because brain areas are active all the time. So it could be some kind of noise that is mistaken for a real smell. And that's maybe why it's an unpleasant smell most of the time. So I tend to think that there's some kind of misinterpretation of neural noise in the brain.
Right.
I should say also that we found a link between perceiving these phantom smells and a gene, the BDNF gene,
Oh, wow.
that is known to affect plasticity in the brain. So that could, if you have the different versions of this gene, it might make your brain more plastic, and that might make it easier to misinterpret these noisy signals.
So are you saying that a more plastic brain, a brain that had this gene, would be more likely to experience phantosmia?
Yeah, that would be the interpretation, yeah.
How fascinating. There's something that I've noticed people talk about, and I'm wondering whether this is a sort of neither parosmia nor phantosmia, or some sort of hybrid of the two. And it happens like this. People with a recovering sense of smell who have parosmia might come into contact with something, for instance, a lemon kitchen cleaner, something like that. And then they continue, they have the impression of continuing to smell this smell all day long. They can't get it out of their nose. That's the expression that's used. And that something is, they have a smell experience that it just keeps repeating and repeating and repeating. Like if you hear a song on the radio, you know, and that you just can't get that song out of your head.
Right.
Like that.
Okay.
And so if we think about phantosmia, if the definition of phantosmia is being the experience of a smell that is not present, then this first smell signal, you know, 10 hours later is being experienced not in the presence of that original smell. So I just wonder what, if you haven't, I mean, I don't expect you actually to have any particular knowledge of that, but Do you think that that sort of thing is possible?
Yeah, I think that makes sense to me. You know, the just like we can have an earworm, a song that we can't get out of our heads.
Right.
That would be sort of a noseworm equivalent
Yes.
of the earworm.
Not a good image, is it?
Oh,
But I do think that Phantosmia is probably, there might not be one single explanation for all types of Phantosmia. So there might be, you know, different explanations for different people. I know I can just give one anecdote from this study that we published. One lady said that she had a phantom smell of her late husband's cologne. So it was like a memory of him that she couldn't get out of her mind. So that's sort of it's just one person in our data set, but it goes to show that, you know, there can be autobiographical components too. So there are probably many different mechanisms.
Very interesting.
interesting. Yeah. We have a question here which asks, brain fog is a common symptom of COVID-19. I've read that smell training can improve cognition in general. Do you think there is any prospect for smell training doing more than just improving our smell?
Good question.
This is a topic that I am currently pursuing in my research group. We published a study just a couple of weeks ago about smell training for improving memory. So what we did was, in healthy participants, we created a memory game. It's sometimes called concentration, where you pick out matching pairs. So we created a smell version of this game, and we sent people home with that, or with a visual equivalent, and had them train for 40 days. And when they came back to the lab, we tested them on smell tests and on the memory tests. And we found that, yes, the smell training helped people very much in terms of their smell abilities. They became, on some tasks, as good as a group of wine experts, sommeliers, after just 10 minutes of training for about a month. But they also became better at this visual task. So training with the smell task made them better on the visual task, but those who trained on the visual task did not improve on the smell task. And so we're currently exploring whether training different cognitive abilities using smells, so for example memory abilities using smells, might help for the learning effect to be generalized across a wider range of study materials and circumstances. So we have a few studies in the pipeline where we try to show that. So it's at least an interesting possibility.
And tell me, what does a smell memory game actually look like? Do you have 2 bottles of each scent? Is that what happens?
Yeah, we have a game board with 24 small tea cans, basically small tin cans that we have filled with white tea bags, basically. So it's they're matching different tea flavors based on their smell.
Right.
Yeah.
You don't see many board games like that, so it's quite an interesting game in general. Yeah.
I can also say we're trying to expand on the smell training technologies, because they are quite primitive. Obviously, you know, it's a bit cumbersome to send people home with a big, 24 tea cans. So we're building machines that they can put into their computer that can help them smell train. So we have a couple of those types of machines that we think will make it easier to smell train in the future. And that way you can also log your response, and the computer can adapt the difficulty. Once you get better, the computer will give you more and more difficult questions about the smells.
Interesting.
Very interesting. We have Barry here asking, Jonas, hi. You say that the brain prepares us to expect what we are going to smell. So does this mean that we use all the sorts of other sensory cues to generate these expectations? What we see, what we hear, what we feel, etc.
Yeah, that's what I think, and I think that so a popular sort of trend in brain science right now is theorizing about prediction, so that the brain is basically the reason why we have such a big and powerful brain is that we can make predictions, because predictions are good, you know, when we want to navigate in the environment. You know, we make predictions on all kinds of things, and this happens automatically. We don't have to think about it. So I don't think that smell is an exception to that rule. The brain predicts all kinds of things, and what many experiments have shown is that brain reacts most strongly to things that we did not expect, whether it's a noise that we didn't expect, or something that flashes by, or a strange smell. The brain really fires up. So I think that yes, the brain tries to predict what we are smelling, and usually it's pretty good at it. But when there's a mismatch, that's when we are really startled, and we try to figure out, what is this? Should I be worried about this smell, or is it okay?
Mm-hmm. Okay.
Okay, can we just pause the questions for a moment? I want to go back to the sort of the list of things that I wanted to discuss with you this evening, and I wanted to especially ask you, because this is something that also comes up quite a bit in the Facebook group. What happens to the brain when smell messages stop going in? I'm thinking about the olfactory bulb, and you know, what can you paint us a picture of what happens when the brain is no longer receiving smell messages?
There are some rodent studies on rats and mice that indicates that the olfactory bulb stops regenerating under these conditions, when the animal doesn't get any smells. This sort of natural process of neuronal recycling, there's a recycling of different chemicals in the brain, and even in some cases new nerve cells are being produced and transported within the brain. So that kind of process needs some kind of activity to be ongoing. Otherwise it shuts down, or the activity becomes lower. So you can say that the olfactory system degenerates to some extent from deprivation. But the flip side of that is that smell training and recovery will help to recover those functions, and then you can see that it's not irreversible. So it's just a consequence of deprivation versus activation.
Right.
But and you can see also that in studies with patients who have recovered from smell loss, that the olfactory bulb and the olfactory tract is becoming a little bit thicker.
Right. And
there are studies also on perfumers, for example, by my colleague Jean Plailly and Jean-Pierre Royer in Lyon, that has studied French perfumers, and certain regions of their brains, the orbitofrontal cortex, for example, has a thicker cortical surface than in novices. So you can make it even thicker probably if you're a perfumer and that's your job. Over time, that region will get bigger.
Right. Excellent. Well, yes, so that you confirm what I've always believed. So yeah, that's great news. Um, right, Aidan, shall we go back to the question bar? What are people saying now? I see we got more and more questions.
Sure. Okay. If you have a threshold issue caused by COVID-19, meaning you can smell most things if they're very close to the nose, is smell training likely to help with it? What is the prognosis for getting back to the original threshold?
Chrissy, do you want to go first?
Yes, a lot of people complain about this. They'll say, I can smell it when I hold it up next to my nose, but I can't appreciate any kind of ambient smells. And I can only speak from experience and say that, ambient smells obviously are weaker, but if you are lucky enough to recover and you are good with your smell training, you will have that experience eventually. But it doesn't happen overnight, and smell training is like physiotherapy. You have to do it in order to reap the benefits of it. And no one ever became a concert pianist in a week, so you have to really keep up with it. But there's nothing magic about ambient smells. They're no different from any other kind of smells. It's just that they're more distant and they're a little bit weaker. So I think that, people should feel optimistic about this and should keep smell training.
With the COVID-19, it's such a new kind of phenomenon that we don't know very much about ways to improve the recovery phase in COVID-19. I'm sure these studies are going to come out sooner or later, but it's hard to tell, in my view.
Yeah.
We have someone else here from Sweden, so they say hi. They say that they've been smell training for 3 months now. They say, when I smell train, many of the oils and spices I can pick up something that doesn't smell the way they should. How does this affect the training and recovery? Because I feel that it's getting harder and harder to remember the right smell when I train.
Well, obviously, this person has described parosmia, which is a problem that is facing many people who had COVID-19 related smell loss. I think I can say with a certain amount of confidence that obviously we don't know yet exactly what the outcomes are going to be, but that from what we know about pre-COVID post-viral smell loss, the chances of recovery are good, and that parosmia is a phase which is accepted as a sign of regeneration, and that you just have to wait for it to pass. But I think probably smell training is a good thing, because smell training will encourage the regeneration, and that's really what you want, and you will, you'll get there in the end.
Sure.
Do you have any thoughts, Jonas?
Yeah, in terms of the materials used for the smell training, I think a general lesson from cognitive brain training is that using a wide variety of materials is usually a good thing. So the most successful brain training programs, sort of apart from smell, they use a variety of tasks and they use a variety of materials. So training broadly is usually more effective than sort of focusing in on just one thing, and that might give some benefits also here to mix it up and use different smells.
Yes, absolutely. And I mean, there's so many things in your environment that smell that are not obvious choices. Everything from rubber bands to the coins in your coin purse. Everything has a smell to some degree, and I think it's always worth, well, it's a great thing to get into the habit of smelling things. Sometimes it looks a bit strange, but you know, I am a great believer in that as well. So yeah, smell a broad range of things, definitely.
Sure. Be curious about smell, yeah.
Exactly.
Someone asks here, when and if smell returns after COVID recovery, should I expect it to be gradual, or will it come back as quickly as it left?
Well, not to jump in on before you, Eunice, but there certainly are people who've had COVID-19 smell loss who are recovering very, very quickly, let's say a week or 2 weeks after they lost their sense of smell. And because the onset of smell loss with COVID-19 is often so abrupt, people who don't experience this very fast recovery are waiting around for it to kind of switch on again. But I think for people who have been without smell for a number of weeks or months, they should expect a very gradual recovery and not a switching on just instantaneously. Do you, anything else to add on that, Eunice?
No, I think you said it well.
Yeah.
Okay, so we've got a question here more related to smell training in itself. How often should we change essential oils, Chrissy? Should we always smell the same essential oils in the same order, or should we vary?
Well, as Eunice was just saying, you know, smell of a broad variety of things. And I mean, the smell training kit, the way it is, if you keep it carefully, keep the lids on in between, and don't store it anywhere where it gets overly warm, like under a lamp or in the sun, then it will easily keep for 4 months and longer. But when the time comes that you want to change them, then you can wash out the jars and replace the little absorbent discs, but just bear in mind that the lid will have taken in some of the smell of the previous these previous essential oils. So it might be a good idea to get some new jars. But yeah, mix it up, definitely, definitely. I see we have an interesting question here from a coffee taster. Would you like to read that for us, Aidan? From Norman.
Yes. Norman asks, as a professional coffee taster, I'm currently visualizing my Prognosis recovery as a baseball pitch. First base were the first recognitions of basic aromas in a somewhat illogical way,
Yeah.
after 2 weeks of full anosmia. Second base is more or less reaching that halfway marker. About 50% is detectable, though mostly is close and direct to the nose. In coffee, just smells like coffee. Third base would be my 95 to 100% marker. This is a frustrating long pathway at the moment, only grasping maybe 5% per week. But then the fourth, the home base, where I would fully and professionally be capable of detecting all aromas in ground and brewed coffee again. First, the last specializing stage. I have trained on the job for the last 7 years, become a professional and certified taster. I'm quite confident that I will reach third base this year, but can I expect that reaching home base will take less than 7 years again? Or will I have to relearn my brain for a certain part, or all of this period?
Oh dear. Tough question. I don't think anybody knows the answer to that question, Norman. You know, we just don't know the answer to that. I would say if coffee smells like coffee at second base, you're doing pretty well, because that means you will have bypassed parosmia. And if you are lucky enough to have beaten parosmia, then you're doing really well, and I think things look good for you. But I'm very sorry to hear that someone whose career depends so much on such a nuanced ability to smell. I'm really very sorry to hear that, and I wish you a speedy recovery. That is very sad.
And
Right.
if I may add also this ability to visualize the recovery period and the goals of the process. This is very good, and this is very inspirational. I think it's common in sports psychology, and it gives a sense of purpose to the process. So I think that's also, you're looking at it in the right way and keep on fighting.
Yep. Yep.
We have another question here asking just now, does a metallic taste in the mouth have any connection to anosmia?
Jonas, what do you think about that? We hear about that a lot. I think it is, and also people mention burning mouth syndrome, all kinds of sensations in the mouth that are unpleasant. What do you think about that?
That's unfortunately it's not in my topic of expertise.
Right.
And this is a COVID related loss.
Yes.
Yeah, there's so much we don't know about that. So but since it affects smell and taste quite profoundly, and often jointly, those things might go together.
Right.
It's really a heavy impact on the chemical senses.
Right. Yeah.
Mm-hmm.
Yes, I think that can be very bothersome, especially if it's a sort of metallic taste. And no one knows whether or not this is the same sort of disturbance in the mouth that people who have chemotherapy experience, but that would be something, maybe we'll learn more about that soon.
Another one here. Does loss of smell from COVID-19 go along with a dry nose? I'm used to constantly having a running nose before having COVID, but it is totally dry now, and I'm unsure if the smell loss is connected to the dryness.
We have a lot of reports of this, this sort of unnaturally clear breathing passages. So it seems to be a feature, but I can't really tell you any more than that. I don't know. I don't know. Right. Let's see. Shall we go back to our list? We talked a little bit about the top-down effect and the sommelier effect, Jonas, and the importance of that in visualizing smells as we smell train. Do you think there are any other sort of brain training techniques that patients could use as they were smell training that might enhance that activity?
Well, I think it depends on where they are in the process. So if you can hardly smell anything, or even not smell anything, it's going to be very difficult to do some of the exercises that a healthy person can do in terms of remembering or finding matching pairs, like the memory training work that we've been doing. But I think that what we are trying to do now is to present people with labels of common smells, and then have people mentalizing and focusing on trying to reignite that mental smell image of a familiar smell, and then actually smelling it. So you try to consciously evoke the image of a familiar smell before smelling it. That would be I think the most basic way of engaging the whole brain in a way in your smell training. So focusing on what it is and the specific quality that you have. Another way could be to focus on personally relevant smells and think about the memories when you are smelling a particular a particular smell.
Right.
So if you have autobiographical memories from childhood, there was a particular candy that your grandma used to give you, you can use that in smell training, and
Yeah.
try to tie the smell to your memories of that, those events.
Yeah.
That's a very powerful thing that the sense of smell can do, is to bring us back in time.
And there's always Play-Doh and crayons.
Right.
Two things that have really strong smell that
That's right.
is very evocative for people.
That's right.
But I noticed that there are some people that don't seem to be able to remember a smell or conjure up a smell, who very quickly forget, what is mint, or what are lilacs like, or what is the smell of oranges. So I think that can be a real challenge if you're not set up to have those to have that talent.
Yeah. People are not particularly good at doing that mostly. So that's a problem in imagining smells. But we're certainly not as good in imagining smells as we are in imagining visual events, which is quite easy. So in fact, when I tell my students, when I teach about the sense of smell, I tell them to try to imagine the smell of an orange.
Right.
And then it turns out that everyone sees the orange in front of them, but only some of them can actually smell it, So it doesn't come easy, but some people are pretty good at it, and yeah.
Good. Let's see. Let's take a couple more questions. We've got just a few more minutes. Now, here's a very interesting question. Is it better to smell train with smells that we are able to perceive, or with smells that we cannot smell, in order to improve this? I always say yes, keep smell training even if you can't smell them. Although I'm sure that it's more rewarding if you can have a couple at least in there that you can smell. And again, try and visualize what it is that you're trying to smell.
Yeah, I think that it's more rewarding, and I think to the extent that the brain thrives on activation, you get more activation out of something that you can smell than something you can't smell.
Yeah.
But you might also want to mix it up, so you sort of cross train your olfactory system, so maybe you can have a mix of things that you can detect and things that you cannot detect, and it might generalize after a while.
Yeah, when the last event with Thomas Hummel, he was saying that it might be a good thing now, I think, according to some work that they've done recently, to have more smells with more layers to them, a smell that might have a trigeminal component as well, to make the smell more complex. And that would be a more stimulating experience than just these sort of, let's say, single molecule like PEA or something like that. So yes, that would be, yes, I'm not quite sure how you would create that in your smell training kit, but I mean, as an example, eucalyptus has a trigeminal component, and that or ginger, so that would be important.
We used we thought about that without having much data to go on, but we thought that regular tea flavors are pretty complex actually, and they're pleasant mostly, and they have different notes, and
right.
So there's a lot of sort of household products that are quite complex.
Yeah, tea bags are a wonderful idea because they're lightweight, and they're not terribly expensive, and yeah, I think that's a great idea. Great idea. Right, I think we'll take one more question and then time will be up. Is there an answer as to how long the neurons take to grow back? I lost my smell completely back in March and was really quite sick. It came back 20% about 3 weeks ago when suddenly parosmia kicked in. So do you have any feeling on how quickly these nerves regenerate? I mean, it seems a very slow process.
Yeah, I I think it's quite individual, and also the neural part of this regenerative process is not the only thing that happens in the brain when we smell train and when we recover. There's also vascular parts. You know, capillaries start to grow that provide the neurons with oxygenated blood. The neurons that do exist can change in their structure. They grow new branches to improve their functionality. So there's a bunch of things happening in the smell brain during this time, and it probably takes, you know, different amount of time for different people. So it's hard to make general general statements. At least I'm not confident to say anything certain about
Right.
that.
Right. Good. Well, I think I'm afraid time is up. So I will say thank you very much to Jonas for joining us this evening. It's been a great pleasure and it's been a fascinating evening. I've been looking forward to this for a long time. So thank you so much. And maybe you'll come back again sometime. Thank you, Aidan. We will be here again in 2 weeks. I will be speaking with Ilona Croy from Dresden and Professor Barry Smith. We will be talking about feelings of well-being and more to the point, loss of feelings of well-being that go along with smell loss and why this should be. So I'm sure that will be a very interesting evening as well. But to everyone who's come tonight, thank you for joining us. We will see you another time. And of course, this recording will be available on YouTube as soon as I get around to editing it and putting it up. So thank you very much, everyone, and we'll see you next time. Thank you, Jonas.
See you all now. Bye-bye.
Bye.